Before we get into any technical details about the Kotlin language, computer science, and software development best practices, we are going to practice writing some Kotlin. Now, for beginners and junior developers, I don't want you to worry at all about trying to memorize anything. Follow along with me and actually type out all of the code, despite the fact that you will be completely unfamiliar with it. I will type out comments for each significant line of code that we write in simple language so that you have some kind of idea of what's going on. This is learning by doing, not memorization, and I need you to trust me that this is more important than just like reading documentation at this point. Now, you may also write down the comments I make, which might improve the learning experience a little bit more, but the best thing for you to do would be to try to write down comments for each line in your own words. But like I say, this is meant to be a low pressure, low stress exercise. Take your time. Don't worry about trying to remember everything. Just let your hands do the learning for this particular exercise, and I'll talk you through the whole thing. So that's basically it. Let's get started. What we're going to do is we're going to code out a little simple calculator application. So what I want you to do is in the resources section of this lesson, you're going to find two files, which will probably be called Kotlin demo. One of them called kotlindemo.kt, which is a file you would open up if you do have an IDE like IntelliJ. And then there's also going to be a TXT version for those of you who are just working with the web browser and text here. So I want you to open that file up and just have it ready to go. And in that file, you're going to find a complete problem statement for this application. Now, I will go into detail about how problem statements work in part 5, but we're going to look at it really quickly because this is going to tell us what we're actually building here. And this is actually a step I do before I write the code in my actual application. So I'm teaching you something useful here. All I want to just point out here is that we're stating very explicitly that this program is only going to work if the user inputs, and the user is going to input things up in this box up here. So that's where the user input comes from in this case. It's only going to work if we get a plus, a minus, asterisk, or a slash in our program arguments. Otherwise, I just want to display an error message. So that's all that's being written out here is we're saying if the first argument of the program matches one of the above strings here, then execute the appropriate mathematical function, so do the calculation, and then display the result. So we have these kind of itemized steps here that we need to build functions for, and then we also need to pay attention to problems that occur when the user doesn't give us what we're kind of expecting them to. So without much more rambling, let's get started writing the code. So in basically every application you write, one of the first things you want to do is you want to ask yourself, what sort of information or data about this program I'm writing doesn't change? So it turns out that I've already kind of done the work for us, but we have these things right here. We have our mathematical operators. So the very first thing we're going to do is we're going to represent those things as specific references. Don't worry about what that means, just follow along. So I'm going to type val, and we're going to say add. So this is uppercase. Usually for constants, you're going to want to use an uppercase naming scheme. It's just the convention we like to use. So this is going to be add colon string equals plus. So what we're saying here is we're saying let's make a string, which is a collection of letters. I'm not sure if it's, oh yeah, it'll allow the brackets there. It's a collection of letters, just, A, B, C, D, E could be a string or it could be one long. Let's make a string with a name we can use to refer to it. The name is add in this case. And then we're actually going to copy and paste that down, and we're going to do these things we're going to make these references for all the different constants that we have in this program. So this one's going to be subtract, and of course we'll fix it. Now here's right off the bat, a little trick in Kotlin is that Kotlin is smart enough to know that we want a string. So a string is the type of reference we're creating, And in this case, we can actually just remove that. I'm going to leave the top one so you just remember that. But there's a lot of cases in Kotlin where you can kind of skip little steps just to mean you don't have to write as much code. So it's really quite handy. So we've got subtract, multiply. I usually spell that wrong. That looks good. And then we have divide. So the other constant that we need to make is obviously up here. I say specifically, we want to display an error message in the console. And I'm pretty sure I don't need to make like a dynamic changing error message. So we're just going to make a generic error message. It's going to literally be called error underscore message. And it's going to be a string which equals an error has occurred. Just like that. So those are kind of the main constants that we need to make. Now, one of the things I'm going to do in this application is we're going to let the user input their choice of operator, but we're not actually going to let the user input the operands, the numbers in this expression for this little program. I know it's a silly program, but I'm trying to just keep this very simple in the beginning, so just bear with me in that regard. Anyways, what we're going to do is we are going to create two basically test operands to see if our program works properly. And so all we're going to do, again, just using val, don't worry about the finer details, we're going to say test operand 1 equals 5.0. It's important that you put the 5.0. Don't do 5. If you do just a 5, Kotlin, much like up here, it's going to interpret this thing as being an int if we do the 5. But with the 0, that's actually of type double or float. We want to use double. What's the difference between int and double? Double is like a decimal number. Integer doesn't have any kind of decimals allowed. So that's just the basic difference there. But again, we're not going to, I'll leave that one up there and we'll copy and paste this down. And then just so you know what's going on, that can be left out because Kotlin's going to infer that it's a double type with the 0.0. Anyways, let's go ahead and make that a 4 and carry on. So what we've done here is we've basically set up all of the different information which we need for our application in order for it to function properly, which is oftentimes the first thing you want to look at when you're building a new application. So we've got our information, but now we need to figure out what to do with that information, if you know what I mean. So what we'll do is in basically every program we're going to be writing in this particular course, we're going to need an entry point for the program. So this is where the execution of it starts. And so how that's going to work is we need to create this thing called a main function. Now, if you come from a Java background, you're going to already know what this is, but basically when this code gets compiled or turned into something that a computer understands, it's going to look very specifically for a main function, and it's going to know that this is where the developer wants the execution of the program to begin. So we're going to type fun main. We're going to type all this garbled text here, and if you're a beginner, don't worry at all about what this stuff means. Essentially what this thing is here is it's like a data container for what we pass in for the arguments. So if I were to type potato in here and then hit the run button, I could get a hold of that potato by typing args square bracket 0, and that would get a hold of the first thing. And let's say, for example, I hit space, I don't know, blin, which is Russian pancake, more or less. If I wanted to get hold of that one, because it's the second string in this array, which is like a collection of strings, don't worry about memorizing this at all. Then we would type args.1. So just so you see how the pattern works there. Anyways, what we're going to do in this main function is we're going to create another little reference, and we're going to call this val operator symbol. So in the code before, I actually had this just as operator because we're talking about a mathematical operator. But then I remembered that this is actually a reserved keyword. So we're going to type operator symbol instead. So that's why the name is atrociously long here. And then, so what's going to happen is whatever we type in here, we're going to assign that to this operator symbol reference here. So that's the first thing we do. We get the inputted data from what the user types in. And again, the compiler is going to know that this is the first line we want to execute. in this program. And then it's going to read them kind of from top down. So it's going to go from 33 to 34. Now, it might jump around, as you'll see in a minute. It doesn't always go from like line 1 down to 100. It jumps around, but for the purposes of this function, they always go from top down in that manner. Anyways, so what we want to do is, like I say, we want to break this up into individual steps and individual functions by extension. So again, don't worry too much about what I'm doing, but I just want you to type start, bracket, and in the brackets we are going to feed this start thing an operator symbol. We're going to give it that thing we just created up here. Now it's showing up red if you have on-the-fly type checking on the bottom right. My face might be blocking that, and there are kids screaming outside, so we're just going to carry on anyways. And we're going to hit fun start. And so what's going to happen here is that when the computer looks, it goes from this line to this next line, it's going to go, oh, okay, we want to jump to the start function, and we want to give that start function something here. So what we're going to do next is we're going to set up our start function. So what it's going to require is it's going to require one of these things. So we want to type operator symbol. Now, I could actually name this something different. This is a new function. It's a new thing. It creates a new reference here. We're not actually passing this reference through the brackets, but we're actually creating a copy of the address that this reference points to. That's stuff that I'm not going to go into detail there, but we can call it whatever we want is the point of that little rambling. Then we're going to type string. This is the thing that has to be the same. If we're passing in a string here, it has to be string down here. Let's fill out the body of this function. So whenever you're typing the body of functions, with the exception of a trick I'll show you later on, you always put it between these curly brackets. And what do we want to do on our start function? So it's called start, so it's obviously going to be our starting point here. And so the first thing we're going to look at in our problem statement is we're going to say, okay, if the first argument of the program matches the above strings, so one of these ones up here, execute the appropriate mathematical function. This is basically step one in both potential paths that our program can take. So we need to write some kind of function to check what the first arguments are and if they match. So what we're going to do is right off the bat, we're just going to type in here, we're going to make another function, and this is how I actually build stuff. So this is, I'm not teaching you a silly way to do this. This is kind of the right way to do this. What we're going to do is we're going to type if, and just bear with me for a minute. We're going to type a bunch of stuff out, and then I'll explain what it does afterwards. We're going to type if brackets check arguments, which will be the name of our function which does the checking of the arguments. You can give these things good names, guys and girls. So we're going to type if check arguments operator symbol. So again, we're passing this thing in. And this is like this if statement here, it takes in a true or false statement. So whatever this check arguments thing does, it needs to give us back a true or a false, which we call a Boolean. So what we'll do is we're going to just like stop right there. We're going to go ahead and type out this check arguments function. So again, we're going to say fun check arguments. It's going to, let's just copy and paste this in here, honestly. It's going to take exactly the same thing, but we're going to do something different. So functions don't always have to return anything specifically. Technically in Kotlin, every function always returns, and the way that we specify when we want to return a value, we specify this little colon here. Technically every function in Kotlin, if it's just blank, like so, always returns this unit thing. Don't worry about that for now. It's just a whatever kind of just return something type deal. I'm not going to go into fine detail there. In this case, we want to return a Boolean. And so returns true or false, which is what a Boolean is. It can either be true or false. Those are the two states that are allowed. Returns true or false based on if the operator matches our constants, like so. All right, so we type out our function declaration, then we have our return type, and then we go with the curly brackets again because we want to actually type out this function. So let me just scroll down and find my place. So in check arguments, what we're going to do is we're going to use a when clause. It's kind of a cousin to the if clause. So we type when, and then we're going to give it this operator symbol. When operator symbol. Then we type some more curly brackets. So this is the body of the when clause or when matcher. I'm not sure what the exact name for it is, but I don't really care. And then what we're going to do is we can give it a list of different things to check against. So when operator symbol, I'm just going to type in kind of like a comments here, equals. So it's just like an implied thing that we're going to be comparing this thing to something that we're typing within these brackets. When operator symbol equals add, which is our constant up above. When it equals add, and then we need to type this arrow, so we go dash right arrow. When it equals this thing, then there's something specific we want to do. Well, what do we want to do? Let's go back really quickly to the problem statement. Okay, if it's one of these guys, we want to return true. So in this case, we're going to type return true. True is one of the states of the Boolean value. Hopefully that's clear at this point. I'm going to copy and paste this. And we're going to type, so we've got subtract. This is a lot easier when you have an IDE and it auto-completes for you. We have subtract, multiply, and divide. And there's one more case. So what if it happens that our operator symbol, whatever we pass in here, does not match any of these different cases? If that occurs, we need to write what's known as an else. So this is like, if it equals any of these things, do this. Otherwise, or else is a perfectly good word in English to describe otherwise, but otherwise do this. So in our otherwise case, we want to return false. Now, just really quickly, I'm going to show you a trick in Kotlin. Again, there's lots of these little tricks, but we can actually lift this return keyword here and put it behind our when clause. And then we can delete these returns, if it'll let me do that quickly. And then this will work perfectly fine. So these are lots of little things in Kotlin where you can just kind of streamline things a little bit. Okay, so we've got our check arguments function, and it's no longer screaming at us here because of our check arguments function. And so what we'll do next is we'll carry on coding out this if clause. So if this thing passes, if it returns true, obviously we want to go ahead and display the result of the equation that we're trying to solve. So in this case, we are going to write a function called evaluate binomial. And this function is going to take in our two test operands up here and our test operator. So we could type test operand 1, test operand 2, and then operator symbol, just like so. And of course we're going to need to type that one out, so we can go ahead and type evaluate binomial. Hopefully I spelled that correctly. And really quickly, these are all strings, so I'm just going to use short names, so we're going to call this op1 string, op2 string, and we're going to call that sim for symbol string. So we've got our three different strings going in here. I forgot to type fun because I suck at programming. And what we're going to do is we're going to hit our curly brackets up one more time. This thing is complaining because I just realized that we don't actually want to be passing in strings. We want to be passing in doubles. So hopefully you caught that before I did. That's what happens when you're busy trying to write all this code out. Okay, so we accept two doubles and our string. And what we need to do is we need to once again check and see what this symbol thing is before we select the appropriate equation. So I'm actually just going to copy this when clause here because it has a lot of the code that we need to write, and I'm going to paste it in here. And what we'll do is this thing is going to return a string, which will be the result of this adding this equation up or dividing, or whichever one we choose to do. And we're going to check operator symbol again, except we're going to type sim because that's what we've renamed it to at this point. Just going to get rid of that stuff. And we're going to do something a little different. So we're not going to return true or false. We are going to do a little bit of math in Kotlin. So we're just going to type op1 plus op2. Okay, so that's perfectly valid. We're adding a double, two doubles together, but it's still complaining because the inferred type is double, but a string return type is expected. So what we're actually going to do is we're going to type dot after the brackets, to string. And then we'll need to slap on those brackets here because this basically tells the computer that we're calling a function, is why we add those little brackets on. So what this is going to do, this little line of code, is it's going to add one and operand 1 and operand 2, and then it's going to spit out the result of that in string format, which is what we want to display. Let's go ahead and finish that off for the rest of these different functions here, or choices. So we go like that, little copy paste action, we'll do a minus, we'll do a multiply, and we'll do a divide. And yeah, that works all good. Now, what happens in our else case? So we've actually in this program verified that it will be one of these different operators. It has to be. But because this when case needs to be exhaustive, what we're going to do is we're just, for the sake of returning something, we're just going to return an error message. And this is actually a good idea because if for some reason somebody called this function, if this function existed in a different project and somebody called it, this could cause problems if we don't have it exhaustive. So it's going to return an error message. Kind of not necessary, but kind of necessary. Okay, so we've written our evaluate binomial function, but we also need to, of course, display this result. So we've made it all the way to step 3, or display an error message. So we need a function to display things to the console, which you'll see in a moment. And this is going to be the easiest function we honestly write here. So this one's just going to be fun display result. It's going to accept a string result. And we're going to do something a little different. So normally in Kotlin and many programming languages, when you write the body of a function, you write it in these curly brackets here. Instead, what we're going to do is we're going to type equals, which is called single expression syntax for single line code snippets. So when you have something that can be expressed on one single line, which doesn't apply to this thing we have here per se, then you can omit the curly brackets and you just do an equals sign, and then you can type in there whatever you want to type, as long as it's confined to a single expression or line. Now there's fancy ways we can, advanced ways we can play around with that, but what we're going to type here is we're going to type system.out.println, and we're going to give this function, is that a capital LN? No, it isn't. We're going to give this function our result that we pass in. We don't have to write this function because this is actually a function in the Kotlin library. And what it does is it's actually going to output things to our console down here. So if you were running this application in, say, like the command prompt or a terminal, it would be equivalent to the console. And that's how we're going to give the result of the equation to the user. So we've written our display function here, but we still need to call it. So I'm going to use kind of a more functional approach here than some people might be used to. And I'm going to type display result. So we're going to call that function. And display result expects a string. And it turns out that evaluate binomial by design returns a string. So I'm actually just going to select this evaluate binomial and just stick it right into display result here. And as you can see, it's going to show up fine. It's not red. We're doing okay. There's one more thing we need to do. So in the event that check arguments does not pass, we want to, of course, type our error message. So what we're going to do after that is we are going to, again, use our else after the if, so just like in the when matcher. And what we're going to type is, again, just display result, but instead of all that crap, what we're just going to type in display result is error message. All right, so I believe that is everything we need to type in this program. So what we're going to do next is we are going to try and execute the program with a function, with a proper operator, and we'll see if we get a result. Now it might fail. I'm not going to edit this out if I made a mistake. We'll just run it and see if it works. And as you can see, we gave it a plus, and down here in the console window we have 9. So as far as I'm aware, 5 plus 4 does equal 9. No, I'm just kidding. Obviously it equals 9. Let's test out maybe divide. 5 divided by 4. I'm not even sure. It was a 0.25. Okay, that throws an error message. That's wonderful. Let's try multiple. Oh! Huh. Maybe that's what the issue was. Let's try that again. Oh, what do you know? That looks like the right answer. So I wonder how many of you caught that. And I'm going to be honest, I didn't actually deliberately do that. But now you see why testing your program is a good thing for you to do. Anyways, moving on. So we've tested out some things that are supposed to work. And as you can see, I caught one of my mistakes, which is a common thing that we all do all the time in programming. And we can fix that with testing. What we're going to do now is let's test what happens when nothing valid is inputted. Let's try running that, see if it matches. And hopefully we get an error message. We totally do. An error has occurred. So that's it for this coding exercise. Again, I know this probably was pretty intense for some of the beginners. Don't worry that we won't have this long. Not all of the coding examples in this course are this long, but this is one where I just wanted to really get you to practice doing a lot of typing in Kotlin. So hopefully that was kind of fun, and hopefully your program is executing. All right, so if you really are a beginner to programming, now would be a good time to go find a friend or family member and show them that you have written a functioning application, which is no small task. So congratulations. For the more advanced developers, I'm sure parts of Kotlin syntax seem strange to you, but as you practice further, I think you'll start to appreciate the advantages it has over many other languages, particularly Java. Listen, I was a Java developer before I started into Kotlin, and all the different things in Kotlin tended to irritate me, but once I actually learned how to use them, I started to figure out how it might be possible to write the same application in like 40% less lines of code. So do me a favor, stick with it, and I think you'll start to see the light soon enough.